Hello students, welcome back to our data structures questions and answer series. Here I am going to explain some more important questions for your interview preparation. Again, these are helpful for your university exams also. The first question is, what is stack data structure and what are its applications? See, data structure is nothing but a way of organizing data so that it can be used efficiently. There are multiple ways to organize data. There are multiple ways to store data inside a memory. Okay, and according to that there are multiple types of data structures. For example, there is a stack data structure, array data structure, queue data structure, linked list, graph, tree, and there are different types of data structure like linear and non-linear. Some comes under linear, some comes under non-linear. From that, stack is one of the linear data structures. See, stack is a linear data structure that follows last in first out approach. Means whatever element inserted last, that will be removed first. That's why it is called as a last in first out data structure. See, this is just a stack of books. Okay, suppose you have kept one book at the bottom, above that one book, above that next book, above that next book, and so on. What is this? This is called as a stack of books. Okay, and here you can see that if you want to remove this third book, then it is not directly possible. You have to remove one by one. Okay, first this topmost book you can remove, after that this one, after that this one, and then this one. Getting? This is the structure of stack, and this type of structure is there inside this data structure. That's why this data structure is called as a stack data structure. See, here I have just drawn one diagram like this is a stack of integers. You can create a stack of any data type values, no problem in that. But see here, currently I am considering stack of integers. This stack is having 4 elements in it. Here it is having only one end, that is called as a top of that stack. You can insert only element above the top and you can remove only the topmost element from this stack. Getting? The process of inserting element into the stack is called as a push operation. Getting? Process of inserting element into the stack is nothing but push, and process of removing topmost element from the stack, only you can remove the topmost element, that is called as a pop operation. That is nothing but a removal or deletion of element from the stack. Always keep in mind, stack is a data structure. It is a linear data structure having only one end, that is called as a top of the stack. We can insert elements only from one end. Again, we can remove element only from one end. That end is nothing but a top of the stack. The process of inserting element into the stack above top. See, currently top is this one. You can insert element here and that will become a top after that. Getting? The process of inserting element is called as a push operation. The process of removal of element from the stack is called as a pop operation. Getting? This is a stack data structure. And one more point, very much important, whatever element inserted last, that can be removed first. That's why this data structure is called as a last in first out data structure. Again, see, whatever element inserted first, that can be removed last. Okay, see, this 5 is inserted first, that can be removed at last only. That's why whatever element inserted first, that can be removed last. That's why that is also called as a first in last out data structure. But normally last in first out, this terminology is used in case of stack. Now there is one more operation you can do with the stack, that is nothing but a peek operation. Peek is nothing but, peek means only displaying the topmost element. See, in case of pop, we are just removing the topmost element, we are just deleting the topmost element from the stack. But peek operation is nothing but only just displaying the topmost element. If you want to know which is the topmost element in the stack, then you have to use this peek operation. Next one is display operation. You can consider display means just display all the elements of stack one by one. Next one is see, you can check whether stack is full or not. That is called as is full operation. Next one is you can check whether stack is empty or not. For that there is a operation like is empty. Getting? What is the requirement of this is full and is empty operations or functions in that stack? See, whenever you want to insert element inside a stack, stack is having some fixed capacity suppose, and whenever you are inserting element into the stack but all the capacity of that stack has been finished suppose, then you cannot insert any more element in that stack. See, while calling this push operation means you are just inserting the element into the stack. First you have to check whether that stack is full or not. If that stack is full, then that is called as stack overflow. Okay, and in that case you cannot insert, you cannot push any more element in that stack. Suppose this stack is in empty. Okay, then how you can remove the element from that stack? Because suppose stack is not having any element in it and you have called this pop operation, means problem is there, means you cannot remove the element from the stack, you cannot pop the element from the stack if stack is empty. In that case means while calling this pop, or see again while calling this peak also, you have to first check whether that stack is empty or not. If it is empty, then you have to give a message like stack underflow. In that case, stack underflow means stack is empty now. You cannot remove the element from the stack because stack is not having any element in it. Getting? These are just possible operations on that stack. If you are considering stack as an abstract data type, then you can just mention there like stack is a linear data structure where the only one end is there, that is called as the top of the stack, and that data structure follows last in first out approach. The possible operations on that stack data structure are push, that is nothing but inserting element into the stack, pop, that is nothing but removing the topmost element from the stack, only topmost element can be deleted, can be removed. Then peak operation, just displaying the topmost element, not removing, keep in mind. Then display means displaying all the contents of the stack. Next one is full and is empty, means just checking whether stack is full or stack is empty. Getting? These are all possible operations on the stack data structure. Now see what are the applications of stack. Stack is a widely used data structure. There are multiple applications of it. First is recursion. You know all programming languages are having function concept, and inside that there is a very much important concept, that is nothing but a recursion. Recursion means function calling itself. Okay, suppose any function you have written and if that function is calling itself again and again, that type of concept is nothing but a recursion. Inside that the function calls are there, multiple function calls are there. That state of all those calls or return addresses should be stored somewhere, and those are stored onto the stack internally. Means inside recursion concept stack is used. Next one is expression evaluation. See, the expressions can be represented with the help of three different forms. Like see, infix expression form is there. Normally we write the expression in infix format. Expression is having operands and operators. If operator is in between two operands, then that is called as a infix form. For example, let a plus b, this type of expression is there, or 5 plus 6 is there, then that is called as a infix expression. Getting? Now there is one more form like prefix, and one more is postfix. Okay, now here prefix means fix that operator. Pre means first operator and then operands. In this way, here postfix means a b plus. In this way we can represent the expressions like infix form, prefix form and postfix form. Okay, and whenever there is a requirement of this expression conversion, means from infix to prefix or infix to postfix, in that the stack can be used. Okay, and next one is suppose you want to just evaluate any postfix expression. In that postfix expression evaluation, again stack data structure is used. Next one is depth first search. See, in graph data structure there are two types of traversals like depth first search and breadth first search. In depth first search stack is used. In breadth first search, means that is also called as BFS, in that queue data structure is used. Means in DFS stack data structure is used. Getting? Next one is undo redo operation. See, suppose you are using any text editor like Notepad, or suppose you are using word processing system, means word processor, then you know there is a undo and redo functionality. Again other applications like Excel or you can say Paint, again multiple operations are there, all are having undo and redo functionality. Internally, these undo and redo operations are using stack data structure. How? Suppose in a text editor you are writing if initially, then that A will be stored onto the stack. After that, suppose you are typing B, then AB, the next string will be stored onto the stack above that. See, first this is A, this is the bottom of stack, then AB. Next, suppose you are typing C. Okay, then A, B, C, this type of string will be pushed onto the stack. Next, suppose you are just pressing undo button, then just the contents of that stack will be popped, means this ABC will be popped and the next string will be popped and that AB contents will be displayed here. Getting? And after that, this AB will be again pushed onto the stack. This is internal process. Okay, means in this undo and redo functionality, stack is internally used. Next one is function calls. See, the next point is function calls. Function calls means suppose one function is calling second one is calling third one. In this way, means a function can call any other function. This is a concept in programming languages you know very well. Okay, now whatever return addresses of those functions should be stored somewhere to keep track of all these function calls and returns. Getting? And those return addresses are internally stored onto the call stack. Getting? Now the next one is a memory management. This is very much important point, means operating systems should internally manage the memory. Okay, suppose inside any function you have just declared some variables. For those variables, for that local purpose, some memory is to be allocated, and after whenever you are coming out of that function, then that memory should be released and that will be managed by the operating system and with the help of stack data structure. Internally it is having stack, okay, and with the help of that memory management will be done. Next one is syntax parsing. See, this syntax parsing is nothing but a concept which is used by compilers. Okay, compilers, in compiler constructor there is a syntactical analysis, then parsing concept is there. In that, compilers use internally stack. Okay, next one is parenthesis checking. Suppose there is any expression like this, A plus B then plus C, in this way. Okay, this parenthesis and this parenthesis, these are balanced or not. Means suppose you have used only open parenthesis and is not having any close matching parenthesis, then it is wrong, syntactically wrong. Again, in programming also this type of parenthesis checking is there, and that will be done with the help of stack data structure. Next one is string reversal. See, in string reversal means what? The string is stack. See, here we can use a stack data structure for string reversal. How? Suppose this is a stack. Okay, currently it is not having anything. We will just go through the whole strings. Okay, we have to traverse through the string character by character from the 0th index up to the length -1 in this way. And one by one character we have to fetch from that string and we will push it into the stack. Now how we can do that? Suppose we have S character. Initially we have S character that we will push into the stack, like push S. Okay, in this way, push S, then S will be here, then next T, push T, then T will be pushed into the stack at the top. Next one is push A, then A will be above that T, then push C. These requests we are giving in this order. Okay, in this way, then we will push, it will push C onto the top. Then next one is push K, suppose, then K will be pushed onto the stack at this place. Getting? Now this is a stack of this string, stack of characters. Okay, now we can pop one by one characters and we can form a new string there, and that will be the reverse of the original string. How? See, we will first pop, because whatever last inserted, that will be removed first. Okay, that's why the last character we have inserted into the stack, that is K, that will be removed whenever we will call pop operation like this. Now see, first time whenever we will call pop operation, then K will be removed from the stack. This is now currently top of the stack, and that we have to attach to the new string, that will become a reverse string. Next again we will call pop operation, then C will be removed and that we are attaching to the reverse string. Next one we will call again pop, then we will attach it to the string. Again we have to call, then this one, again we have to call pop, then we will get this one. we will get S. Getting in this way, we can get a reverse string with the help of stack data structure. Now the next one is backtracking. See, backtracking is a recursive algorithm that is used in optimization technique. There also internally, see, there is a recursion, means of course internally stack data structure is used. Getting these are all applications of stack data structure. There are again many more applications of data structures. Some of them I have explained here. Getting now, what is the stack? Stack is a linear data structure that follows last in first out approach. Now we have to see the next question that is again based on this stack data structure. See, the next question is, what are different possible operations on stack data structure? In the previous question we have already discussed about all the possible operations, like there is a push operation, pop, pick, display, and then is full, is empty. Again some more operations like count can be possible, means we can count the number of elements from that stack. We can find maximum element from that stack. We can find minimum element, like this. But see, the basic operations are like push, pop, pick, then display, then is full, is empty. Here I am repeating all those, but with the implementation. Means if you want to implement that stack you programmatically, then how you can implement that, again I am going to explain in this question. Okay, now see, here this is a stack. Suppose it is having initially 3 elements. This is called as a top of the stack. Now we can implement stack with the help of array or linked list. Okay, with the help of array, with the help of linked list, we can implement stack. If we are implementing stack with the help of array, then that is called as a static implementation of stack data structure. Again, if we are implementing it with the help of linked list, then of course you know linked list is a dynamic data structure, means that is nothing but a dynamic implementation of stack. From that static implementation I am considering here, and I am going to explain all the operations step by step. This stack internally we can store like this. Suppose in this way, see, this is an array. Okay, array will have internally the limited capacity. Of course array is having limited capacity. See, here I am not considering dynamic array, static array I am considering, which is having only fixed size in C, C++, like this. Okay, suppose this is a array and it is having suppose 5 capacity. Okay, index is 0, 1, 2, 3 and 4. You know array index starts with 0, ends with size -1. Currently I am considering size as a 5. Now top, integer top is the one variable we will consider here, and it is initially having -1 value, this one. Okay, -1 is the value and that is called as a top. And whenever we will just do operations on that stack, on the basis of that top value will be changed. Getting my point? Here top will hold the index of topmost element. Here no any element currently in this stack, then top will have -1 value. Suppose these are the elements in the stack, then how we can insert these elements in the stack, that we will see with the help of push operation. Okay, now see, inserting element into the stack, that is called as a push operation, and removal of element from that stack is called as a pop operation. Only displaying topmost element, that is nothing but a pick operation. Displaying all the elements, that is display. Checking whether stack is full, that is full, and checking whether stack is empty, that is empty operation. Now we have to just see all the operations static implementation. Okay, now first is push operation. See, push means here first we will push 5 value in this stack. Okay, now see, currently top will have -1 value. Okay, and now we have to insert element into the stack, means we will call like this push 5. Now what should happen here? Here we have to just insert at the 0th index, because currently this stack is empty, not having anything. See, if you want to check whether stack is empty or not, then you can check here. If top is -1, then you can say that stack is empty. Getting? If there is nothing, then stack is currently -1, then you can say that stack is empty. Okay, now next thing is, suppose push 5 you want to call, then what you have to do? You have to just increment the top value, that is like this, top plus. Then next thing, before that you have to check whether stack is not full. It is compulsory while doing push operation. If stack is full, then you cannot insert any more element in the stack. That's why first you have to check whether stack is full or not. How you can check that? In this case, suppose top is 4. Okay, top is 4 means what? Top is 4 means size minus 1 you can say, or how stored the size of array inside max variable. There is a max variable and it is having value 5 currently. Then you can check whether stack is full or not by using this, like if top is equal to max minus 1. In this case you have to just display like stack overflow. Okay, otherwise you can insert the element. Okay, like else we can insert element, like we have to first increment the top. Okay, means top will become 0 and at that place we can insert the element that is to be pushed. Okay, here push for you we have called like this, means here we can write like this. The array name is suppose A of max size array we have suppose already declared in this way. Now here A of that top is equal to that element that is 5 currently. Okay, you have to just declare one variable, or you can here pass any argument, and that suppose that argument is n, then you can write here n. Getting in this way we can do the push operation using static implementation using array. Okay, means what is push? Push is nothing but inserting element into the stack. We have to call push with one argument, that whatever value or whatever data you want to insert into the stack, that argument you have to pass to this push function. We are doing here this static implementation with the help of array. Now currently initially the top is minus 1. Whenever top is minus 1 we can say that stack is empty. Okay, first push operation. In push operation we have to just first check whether stack is full or not. Means stack overflow situation is there, suppose, then we cannot push any more element in that stack. For that we can check whether stack top is equal to max minus 1. If it is max minus 1 means no more element you can add in this stack. That's why you can display like stack overflow. Otherwise we can do like top plus plus and we can insert element at that place. Suppose that element is here n, then you can place here n. Okay, currently first I will call like push for you. In this case what will happen? Initially top is not max minus 1, that's why this will execute. The top is currently minus 1, that will become 0, and at the top we are inserting the element. Okay, means A of 0 equal to 5. In here 5 element will get inserted, will get pushed. Next I am calling suppose push of 10. In that case again the same will repeat, top will become 1 and at first place that 10 element will get inserted. After that top 12 I am calling suppose, then 12 element will get inserted at this place, means first top will become 2 and then here the element will get inserted. In this way we can do push operation, static implementation. Get it? Now the next operation is nothing but a pop operation. Pop means just removing element from the stack, and you can only remove the topmost element from the stack. Getting? Now see pop, here there is no need to pass any argument to this pop, because here we are just removing the element from the stack, and only possibility is that you can only remove the topmost element. Currently top of this stack is 2 and it is having 12 in it. This is the structure of this stack. Okay, now we have to call pop. Pop means just remove this 12 element and top will become 1. Currently it is 2, then 1, then 0. Getting? Now how we can do this? First we have to check whether stack is empty or not. We know, we already discussed, if that top is equal to minus 1, then we can say that stack is empty. Okay, stack empty means we can say that stack underflow also. This is called as stack underflow situation. Okay, otherwise what we can do, we can just first store that topmost element in any variable. Like suppose there is one variable t, and inside that we can just store the topmost element like A of that top. Okay, in this way. Now after that means here inside t variable there is 12, and like print this value of t, can display the value of t only t, and after that we can just decrease the value of top, that is top minus minus. Here I am not writing the whole instructions in any programming language, this is just a pseudo code. Okay, now see here What we have done, t equals to a of top means topmost element we have stored in some variable, that is nothing but element going to popped. Okay, means removed. Now we have displayed that removed element is t, and we are just decrementing the top. Now this 12 will be removed and we are just decrementing the top like this. Actually we are not removing the 12 from that array. This is now the garbage value. Okay, that's why we are not actually deleting. Actual removal is not possible. Okay, now this will be considered as a garbage value only, and top is now 1. Getting next, again suppose I am calling pop, then top will become 0 and this 10 element will be considered as a topmost element removed. Okay, again I am calling this, then top will become 0. Again I am calling this, top will become -1. Means currently top is -1 whenever we will call that pop 3 times. Okay, and whenever top is -1, then we can say that stack is empty. Now it is not possible to remove any element from that stack. Getting? This is push and pop operation. Now the next operation is peek operation. In peek operation, what we have to do? See, in peek we have to just check whether stack is not underflow. If it is underflow, then we have to give message to the user. Means you cannot display the topmost element because it is empty. Okay, otherwise we have to just do these things like t equals to a of top, and we have to just display that topmost element. Don't do that top minus in peek operation, because in peek operation is nothing but just displaying the topmost element, not removing the element. Getting? Now the next one is display operation. Display means here from top to 0 we have to just display all the elements of that stack one by one. What we have to do in that case? In display, first we will check whether that top is equal to -1. If it is -1, then stack underflow, because no any element to display in this case. Otherwise, see what we have to do here currently, from for loop we have to place here, because we have to display all the elements of array in reverse order. Just we are doing here that thing. Okay, why reverse order? Because first top, then next, and in this way array should, that stack should be displayed onto the screen, like first 12, then 10, then 5, in this way. That's why we have to start from top. Let I variable we have declared I is equals to top I greater than equal to 0. Up to 0 we have to do that thing, and I minus, of course reverse loop. Okay, and just print there a of I have considered here array name as a A. Okay, getting? Means here in this way we can just display the elements of that stack. Next one is empty is full. Already we have discussed while discussing that push and pop. Okay, these are all operations possible on the stack data structure. Okay, the first thing is there is a push operation, means you are just inserting element into the stack. You can only insert above top, means you have to insert the element. Before that you have to increment the top of that stack. Okay, next one is pop, means just removing the topmost element from the stack. Peek means only display the topmost element. Display means display all the elements of that stack, and we can check whether stack is full or empty, that is full and is empty. These are all possible operations onto the stack data structure. We can implement stack with the help of array. In this way we already discussed all the operations like push, pop, display, peek, everything with the help of this array data structure. Getting? In the next session we will discuss some more important questions of data structure. In that I will cover queue data structure. Okay, again difference between stack and queue. Till then, take care. Bye bye. Thank you.